The night sky has always been humanity's silent cathedral, a dome of unknowable depth where stars burn with a patience that mocks the brevity of human lives. For millennia, we have looked upward and seen constancy, a sky where planets move like slow dancers, comets blaze and vanish, and stars hold their positions as if stitched to an invisible fabric. But occasionally, something arrives that is not stitched at all, something that is passing through, something that should not be here. When the object designated 3I, Atlas, was announced, it was not just another catalogue entry in the long ledger of rocks and ice wandering through the solar system. It was a messenger. Its trajectory bore the unmistakable mark of an outsider, an orbit not bound by the sun, a velocity too great to be captured. Like a drifter walking through a city without ever intending to stop, it cut across the paths of our planets with indifference. And in that moment, astronomers understood they were witnessing another interstellar traveler. This was not the first. The name Oumuamua had already shaken the scientific world years before, a shard of something alien sliding silently through our skies in 2017. It was the first known interstellar object, a revelation that proved beyond doubt that our solar system is not sealed, but porous. But Oumuamua could still be dismissed as an anomaly, a cosmic fluke. One in a trillion, perhaps, an accident that might never repeat within the span of civilization. 3I, Atlas changed that. It carried the same foreign signature, the same refusal to obey the gravitational loyalty that binds every native planet and comet. Its arrival whispered of a deeper truth. Our neighborhood may not be as quiet as we once believed. These are not rare phantoms, but echoes of a larger storm. They are shards from other worlds, scattered and hurled across gulfs of space, drifting from systems we may never see. The air of mystery around such an object is heavy, almost theological. To glimpse a body that has crossed the void between stars is to brush against the scale of the galaxy itself. Each interstellar stone is a fragment of history we did not live, a piece of another sun's story that has wandered into ours. 3I, Atlas, does not merely pass, it testifies. It declares that planets shatter, that systems spill their debris, and that the universe is not orderly, but wild and violent. And if 3I, Atlas, is not alone, if it is merely the second voice in a cosmic chorus, then we must ask, how many others slip silently past, unseen? How many carry secrets in their frozen cores? How many arrive without notice, on paths that intersect dangerously with our fragile world? The hook is not just scientific, it is existential, for in the arrival of 3I, Atlas, humanity is confronted with the reality that our solar system is not isolated, not protected, not exceptional. We live in a crossroads of cosmic traffic. The night sky breathes, and in its breath, foreign stones pass through, indifferent to whether we notice them or not. The story of 3I, Atlas, is therefore not simply a tale of discovery but of recognition. It is the moment when the universe reminded us that we are not alone, not in the comforting sense of kindred life, but in the sobering sense of alien matter, alien trajectories, and alien histories sweeping through our fragile home. And so begins the deeper question. If 3I, Atlas, is not alone, then neither are we. Oumuamua. The word still carries an almost mythical weight. In Hawaiian, it means a messenger from afar arriving first, and it was an apt name for the enigmatic object that startled astronomers in late 2017. It was slender, elongated, or perhaps flat like a shard. No one could agree. Its brightness shifted in strange rhythms as though tumbling chaotically. And, most telling of all, its path across the solar system could not be explained by the sun's pull alone. The Pan-STARRS telescope in Hawaii first spotted it, a faint speck of light against the endless backdrop of stars. At first, it was assumed to be another asteroid, one of countless minor bodies drifting in elongated orbits. But orbital calculations quickly betrayed its secret. Its trajectory was not elliptical, not bound, but hyperbolic. In other words, it had come from beyond the grasp of our star, swooping in and already heading back out to the darkness between suns. This was no native stone. It was a stranger. Astronomers felt both awe and discomfort. For centuries, the solar system had seemed to them a closed stage where the familiar cast planets, moons, asteroids, comets played out predictable roles. Suddenly, a door had been opened, and from that door stepped a traveler whose home was another theatre entirely. The realization was like discovering footprints in a place believed untouched. Oumuamua's strangeness was not confined to its orbit. Its acceleration, too, confounded expectations. As it receded from the sun, it seemed to drift faster than gravity alone should allow. Some proposed it was venting gas, like a comet, though no tail was seen. Others speculated that its shape and spin were unlike any body yet catalogued. The debates grew fevered. Was it a shard from a shattered planet, an icy relic from a distant star, or something far more radical, an engineered object, a sail catching sunlight? For the scientific community, Oumuamua was a lesson in humility. One visitor could be dismissed as extraordinary chance, but it forced a re-examination of cosmic probabilities. If even one such body could enter our skies within the span of modern observation, how many more might have passed unseen before? Our telescopes had only recently become sharp enough, vigilant enough, to notice these faint messengers. How long had the night been filled with silent trespassers? The shockwaves spread beyond astronomy. Philosophers, novelists, and ordinary dreamers all felt the tremor of possibility. To know that a piece of another star system had glided through our own was to feel the galaxy suddenly shrink. The gulfs between suns seemed less absolute. The void felt less empty, more alive with drifting relics. And in retrospect, Oumuamua was not simply a curiosity, it was a herald. It proved the principle. Interstellar objects were not theoretical, they were real, measurable, and capable of finding their way into the embrace of our telescopes. Like the first raindrop of a coming storm, it warned that others would follow. When 3I, Atlas, appeared years later, it was impossible to see it in isolation. Its presence was tethered to the memory of Oumuamua, as if the two were parts of a larger pattern, chapters in a story we had just begun to read. Oumuamua had cracked the door open. 3I, Atlas widened it. Together, they forced a chilling, exhilarating recognition. The night sky is not static, not sterile. It is permeable. And the interstellar road that crosses our solar system is traveled more often than we dared imagine. Years after the shock of Oumuamua, the sky whispered again. On a quiet night in 2019, astronomers at the Asteroid Terrestrial Impact Last Alert System, ATLAS, for short, registered a faint streak of light gliding across their survey images. At first glance, it was unremarkable, a blurry smudge against the canvas of stars, the sort of trace that observatories pick up countless times each week. Yet when its motion was measured, something was immediately strange. The object was not circling the sun in a closed loop. Its trajectory bent outward, unbound. This new wanderer was given the designation C 2019 Q4 Borisov, later formally recognized as 2I Borisov, the second interstellar object confirmed after Oumuamua. But woven into the growing network of sky surveys, another detection, 3I, Atlas, followed close behind. Both served as undeniable signals. The universe was not finished sending strangers to our doorstep. Unlike Oumuamua, which appeared as a dark, tumbling shard, 3I, Atlas bore the distinct signs of a comet. It sprouted a halo of gas and dust as it approached the sun, betraying a nucleus of frozen material warmed into sublimation. This made it less enigmatic, perhaps, than its elongated predecessor, but in other ways, it was even more shocking. Oumuamua could be explained away as an oddity, a single statistical accident. Two such visitors, within only a few years, shattered that comfort. If the first had been lightning, the second was thunder, confirmation that a storm was passing through. For the astronomers who traced its motion, the data left no room for doubt. Its incoming speed, nearly 30 kilometers per second relative to the Sun, was far beyond anything native bodies achieve. Its orbit was hyperbolic, its past trajectory pointing unmistakably toward interstellar space. Like a messenger wandering in from the wilderness, 3I, Atlas had crossed the invisible boundary that marks the Sun's dominion. Its very presence raised unsettling questions. If interstellar comets can be observed so easily now, how many others slipped past us before telescopes became so sensitive? Were such objects always this common, or are we living through a peculiar moment in galactic history, when nearby stellar nurseries hurl debris across our path? And, if this is not coincidence, if 3I, Atlas is but one fragment of a larger invisible procession, then the solar system is less a fortress and more a thoroughfare. But beyond its orbital mechanics and physical properties, there was something almost uncanny in its symbolism. With 3I, Atlas, humanity had confirmed that Oumuamua was no singular miracle. Instead, it had been the opening chapter of a larger, ongoing narrative, a narrative written not by us, but by the galaxy itself. Each interstellar object that passes through is a relic of another world's catastrophe. A planet shattered, a comet torn loose, a solar system's discarded bone. And so 3I, Atlas became more than an icy nucleus trailing a veil of gas. It became a reminder of cosmic fragility, a frozen shard of distant history now brushing against our own. If two such wanderers could arrive within a human lifetime, then we must accept a new truth. The solar system is not solitary, it is porous. And we are not isolated, not even in the silence of interstellar dark. To the untrained eye, 3I, Atlas was nothing more than a dim smudge against the night, so faint it could easily have been mistaken for noise in a CCD image. But through the instruments of modern astronomy, every pixel of light was a cipher. Telescopes like Atlas, Pan-STARRS, and those scattered across the globe have become humanity's wide-eyed guardians, ceaselessly scanning the sky for subtle motion amid the fixed constellations. It was through these electronic eyes that the stranger first revealed itself. Night after night, the telescopes accumulated exposures, frames, where stars remained steady, while the interstellar visitor crept ever so slightly across the field. Software flagged the anomaly, and astronomers leaned closer. They measured the shift, calculated its speed, and ran the numbers through orbital models. What emerged was staggering. The path was not a closed ellipse, but an open hyperbola, meaning the Sun was only a temporary bend in its long and endless journey. The data spoke clearly. This was not a child of the solar system. No hidden origin from the Kuiper belt. No long-period comet returning after eons. Its velocity before encountering the Sun was already greater than escape velocity, proof that its roots reached beyond the heliosphere. In those early days after detection, teams of astronomers around the world scrambled to point their instruments toward it. Each night was precious. Every hour of observation might be the last before it slipped again into interstellar obscurity. Spectrographs came alive, splitting its feeble light into rainbows of data. From those colored lines came whispers of its composition, traces of carbon monoxide, water vapor, and dust grains not unlike those of our native comets, yet bearing subtle differences that hinted at alien chemical histories. A haze of gas bloomed around the nucleus, faint but undeniable, a halo shaped by a sun it had never known before. Amateur astronomers too joined the pursuit. Through backyard telescopes and remote observatories, they recorded streaks across the night sky, knowing they were watching something unrepeatable, a traveler that had crossed light years to arrive unbidden. Humanity, scattered across continents, suddenly shared the same visitor, fragile and transient, its faint glow uniting professional and amateur alike in a fleeting act of cosmic witness. Yet what most haunted the observers was not merely its presence, but its indifference. The object was not here for us. It would never slow, never orbit, never return. Its path across the solar system was a brief arc, a silent passing through a stage already crowded with planets and moons. Unlike the bodies born under the sun, 3I, Atlas belonged to a larger, colder rhythm of galactic drift. Astronomers wrote in their notes with a mixture of exhilaration and dread. They had captured data from a body that carried the fingerprint of another star system, an unasked-for gift, fleeting and irreplaceable. In the shifting graphs of brightness, in the calculated vectors of its orbit, lay the evidence of a truth we had long suspected, but never seen so vividly. Our solar system is not closed, but permeable. And as 3I, Atlas receded, already fading beyond the reach of smaller telescopes, a thought remained like an echo. How many others have brushed past us unseen before our eyes were sharp enough to notice? Each frame of data was not just a record of a comet's flight, it was a reminder of our own blindness, a fragment of testimony that the galaxy is moving around us even when we imagine stillness. In the glow of faint pixels and hurried observations, humanity caught a glimpse of something vast, a shard from elsewhere, framed for a moment in the cold precision of telescopes, before vanishing into the silence that birthed it. The discovery of 3I, Atlas, was not merely another point of data to catalogue, it was a rupture in expectation. For centuries, astronomers had constructed an image of the cosmos as a place of stability, where planetary systems formed in isolation and their debris rarely strayed across the gulfs between stars. To see not one, but multiple interstellar wanderers within a short span of years shook that quiet assumption. In textbooks and models, the arrival of such an object was expected to be vanishingly rare, perhaps once in many human lifetimes. Oumuamua could be explained away as fortune, an anomaly, a once-in-a-civilization encounter. But the passage of 3I, Atlas, so soon after, tore that comfort apart. Suddenly, the heavens seemed less serene, less predictable. What had been imagined as improbable had revealed itself as ordinary. The shock was not only mathematical, but philosophical. If such objects are this common, then every star system must be shedding fragments constantly, casting out comets and asteroids like sparks from a fire. The Milky Way becomes not a map of isolated islands, but a turbulent ocean, its currents filled with debris drifting endlessly. The very emptiness of interstellar space begins to feel less empty, crowded instead with unseen travelers. Scientists felt unease in the patterns. If two such objects have passed through recently, then countless more must have slipped past unseen in earlier centuries before our telescopes had the sensitivity to notice. What else has brushed by our world, anonymous and invisible, leaving no trace but the ripple of its passing? The unsettling part was how quickly the narrative shifted. From believing interstellar visitors to be mythic rarities, astronomers were suddenly confronted with a flood of probabilities. Perhaps hundreds of interstellar objects are within reach at any given time, their faint glimmers hidden just beyond the limit of detection. The heavens, once thought orderly, revealed themselves as porous, leaking the remnants of distant systems into ours. This revelation bent the rules of comfort. If so much alien debris drifts across our neighborhood, the solar system is not the self-contained sanctuary humanity once imagined. Instead, it is a way station, a crossroad in a galaxy whose traffic we barely comprehend. The very idea of safety, the belief that our world drifts in cosmic solitude, was broken. For some, this realization was thrilling. It meant that fragments of other worlds might be passing close enough for us to capture and study, carrying within them the chemistry of alien suns. But for others, it carried a more haunting implication. If these objects arrive unpredictably, at velocities too great to control, then the possibility of collision, however small, cannot be dismissed. The sky is no longer empty. It is active, alive with unseen strangers. The scientific shock was therefore not confined to equations or orbital charts. It struck deeper, shaking the way we imagine our place in the galaxy. The solar system is not a sealed vault. It is a corridor, and objects like 3I, Atlas, remind us that we are not alone in it. When the first astonishment faded and calculations were checked again and again, the true weight of 3I, Atlas's arrival, settled over the scientific community. It was not supposed to happen, not twice, not so soon. Probability models built on centuries of observation had painted interstellar visitors as nearly mythical, their chances of being detected within a human lifetime vanishingly small. Yet here was another one, brushing through our planetary neighborhood only a short while after Oumuamua. The odds, as once imagined, had broken. Astronomers began retracing the logic. The Milky Way contains hundreds of billions of stars, each with the potential to host planets, comets, and disks of debris. Planetary formation is a violent process. Collisions, scatter material, and gravitational nudges can fling fragments into the abyss. By those mechanics, interstellar objects should exist, but to actually see them, that was expected to be exceedingly rare, as if waiting for a grain of sand to drift into one's open palm from across the desert. Oumuamua had already cracked that expectation, and 3I, Atlas, split it wide open. The conclusion was inescapable. Our instruments were not catching anomalies. They were catching the first hints of a vast, unseen population. The galaxy, it turned out, might be littered with these vagabonds. The implications were staggering. If two have passed so recently, there may be thousands, perhaps millions, sweeping invisibly through the solar system over centuries. Most would be faint, too dim for our telescopes to register, but their presence alters our understanding of galactic life. Interstellar space is not a vacuum devoid of substance. It is a river filled with drifting debris, each shard a story broken loose from another star. For cosmologists, the shift was as profound as learning that planets orbit stars. It reframed the solar system's relationship with the galaxy. We are not an isolated island, but a node along migratory routes. Every encounter, every hyperbolic trajectory traced against the sun's gravity, hints at a cosmic traffic far denser than previously imagined. The statistical rupture brought with it an undercurrent of unease. If so many bodies are truly passing near Earth's orbit, how vulnerable are we to chance collision? The energy of an interstellar impactor, moving at tens of kilometers per second, would dwarf that of any asteroid born under our sunday. The comfort of rarity had dissolved, replaced by the awareness of possibility. But more than fear, there was wonder. To imagine interstellar objects as common is to realize the Milky Way is not a gallery of distant stars observed from afar. It is a shared ecosystem, a network of exchanges. Each rock or icy fragment that drifts through is a piece of another world, bearing chemistry, structure, and memory from places we may never visit. 3I, Atlas, thus became a turning point. The moment astronomers were forced to admit that their equations of improbability no longer held. The universe had shown itself busier, more dynamic, more restless than we had dared to believe. The shock was not merely scientific, it was existential. What had once been considered impossible was now unfolding as the natural order. Once astronomers accepted that 3I, Atlas, was indisputably interstellar, their attention turned to the line it had carved through the solar system. Its orbit was reconstructed from faint points of light, each observation marking a step along its path. When connected, those dots traced not the comforting ellipse of a comet bound to the sun, but a sweeping curve, hyperbolic and unchained, like the stroke of a brush across infinite canvas. The mathematics of trajectory told a story. Backward integration of its orbit rolling time in reverse, recalculating the gravitational pulls it had endured, revealed that 3I, Atlas, had entered our system from the direction of the constellation Lynx. Before that, it had traveled uncounted light years through the dark, passing silently between stars. Its speed before encountering the Sun was measured at nearly 30 kilometers per second relative to the solar system, too fast, too resolute to ever be captured. This was the signature of exile, the mark of an object cast adrift from its birthplace long ago. But tracing such a journey is not simple. Gravitational encounters with other stars, clouds of molecular gas, even the subtle tug of galactic tides can alter the path of a wandering comet over millions of years. The line astronomers drew through their simulations was not a single sharp thread, but a haze of possibility stretching backward into mystery. The object may have been ejected from a planetary system near a red dwarf, or from the icy outskirts of a young sun-like star, or from a place far stranger still. What mattered most was the recognition. This was a relic of a distant system's violence. Somewhere, long ago, planets collided, or giant worlds slung comets outward with merciless gravity, and in that chaos, this frozen shard was hurled into the galaxy. It traveled for millions, perhaps billions, of years before crossing paths with our Sun, a journey of such scale that human language strains to contain it. The orbital reconstruction also revealed how briefly the solar system would hold it in sight. Its curve bent only slightly as it swept through, brushing past the Sun's domain before resuming its infinite departure. The encounter was fleeting, a cosmic handshake, lasting mere months after an odyssey of eons. For astronomers, the urgency was palpable. Every observation was a grain of sand slipping through their fingers. Once gone, it would never return. The path of 3I, Atlas, thus became more than a line on a chart. It was a reminder that the solar system is not a closed circle but a crossroads. Objects do not only orbit here, they pass through. Their trajectories are like scars across the fabric of space, each marking the movement of histories foreign to our own. To follow its orbital arc backward is to peer into another story, one written under a different sun. To follow it forward is to watch it vanish into silence again, carrying with it secrets of a place we will likely never see. Between those two infinities, we caught it only in passing, an interstellar echo framed for a heartbeat in human time. Every interstellar visitor forces the same inevitable question: where did it come from? For Oumuamua, the answers were hazy. For 3I, Atlas, they were equally elusive, yet tinged with possibility. Its icy tail and outgassing marked it as a cometary body, suggesting it had once lived in the cold peripheries of some distant planetary system, far from the warmth of its parent star. Somewhere, perhaps hundreds of light years away, a star once cradled this fragment before it was torn free. The mechanisms of such ejections are violent. Planetary systems, especially in their youth, are chaotic arenas where giants like Jupiter and Saturn equivalents fling smaller bodies outward. Gravitational slingshots can accelerate comets to escape velocity, hurling them across the void. Collisions between protoplanets scatter debris like sparks from an anvil, some of which fly so far they never return. Over millions of years, such fragments accumulate in vast, distant reservoirs, their versions of our Oort cloud, waiting on the fringes until a nudge sends them spiraling away forever. Astronomers examining 3I, Atlas's trajectory speculated on candidate birthplaces. Its path suggested no specific system with certainty, but computer simulations hinted at dense star-forming regions, perhaps a nursery where suns are born in clusters. In such crowded neighborhoods, stellar encounters are frequent, and comets are stirred like dust in a storm. A close brush with another star could have disturbed its orbit, ejecting it into interstellar exile. The comet's composition added further clues. Spectroscopic analysis revealed cyanogen and carbon monoxide, along with familiar signatures of water, ice ingredients common to comets here, yet subtly distinct in abundance. Such fingerprints whispered of a chemical kitchen different from our own, perhaps a colder disk, or a star of lower metallicity. To study its light was to taste the flavor of another system's chemistry, a recipe shaped by conditions alien to Earth's beginnings. Speculation grew bolder. Could fragments like 3I, Atlas, carry within them the record of planetary catastrophes? Might it once have been part of a larger world, shattered by collision, reduced to shards that drift across the galaxy? Could it be a messenger of ruin as much as of birth, bearing witness to the fragility of distant civilizations of planets? Each possibility deepened the sense of awe, for in contemplating its origins, humanity was forced to expand its sense of belonging. 3I, Atlas was not an alien spacecraft, nor a deliberate envoy, yet it was a message nonetheless. Proof that other systems breathe, shatter, and evolve beyond our sight. The galaxy is not still, it is restless, shedding fragments like leaves into the wind. The mystery of its birthplace may never be solved with certainty. Its trajectory is too altered by countless stellar encounters, its chemical composition too general to pinpoint one star among billions. But perhaps precision is not the point. What matters is the recognition that each interstellar object is a sample of the galaxy's greater story, a shard of an unseen world carried into ours by the inexorable tides of gravity and time. In 3I, Atlas's icy nucleus lies a memory of a place we cannot visit, a record written in frozen gas and dust that formed beneath a sun we will never see. To study it is to glimpse the broader tapestry, to accept that our solar system is but one thread among many, woven into the restless fabric of the Milky Way. As astronomers absorbed the reality of Oumuamua and 3I, Atlas, a haunting question surfaced. Were these truly the first interstellar visitors we had ever seen, or merely the first we had noticed? The more they examined the statistics, the more a quiet suspicion grew, perhaps. The sky has always been seeded with such travelers, slipping past our gaze long before our instruments were sensitive enough to detect them. The solar system is filled with millions of small bodies, asteroids in belts, comets in long icy orbits. For centuries, faint smudges were discovered on photographic plates and classified as new comets or new asteroids, their orbits logged, their returns predicted. But what if some of those faint visitors were imposters? What if among them were objects that never belonged to our sun at all, whose hyperbolic paths went unnoticed or were mistakenly labeled as extreme comets? Only with the precision of modern surveys, Pan-STARRS, Atlas, Catalina Sky Survey, has humanity gained the ability to track faint objects across multiple nights with enough accuracy to calculate true orbits. Before this, the margins of error were wide enough that an interstellar trajectory could be blurred into the illusion of a bound comet. In old records lie candidates, comets with suspiciously steep orbits, asteroids moving faster than expected. Were they overlooked interstellar guests? The thought lingers like an echo. And there is another category: meteors. Each night, thousands streak through the atmosphere, burning up in seconds. Most are tiny grains shed from native comets, yet in 2019 a remarkable claim emerged that a fireball detected over Papua New Guinea in 2014 may have been interstellar in origin. Its velocity, reconstructed from military sensors, suggested a path too swift to be bound by the Sunday. If confirmed, it would mean Earth itself has already been struck by debris from another star system. This possibility reshaped the conversation. The interstellar population might be vast, its members ranging from planet-sized fragments to pebbles smaller than a fingernail, all flowing invisibly through the solar system like dust in a sunbeam. We see only those large and luminous enough to reflect sunlight into our telescopes. The rest slip past, silent and unrecorded. For astronomers, the growing list of candidates was unsettling. It meant the galaxy was not a static backdrop, but a restless exchange of material. Our solar system, long imagined as a closed loop, was instead part of a dynamic network of sharing and scattering, where objects born under one sun could drift endlessly until captured, if only for a fleeting moment, by another. Each candidate object, each suspicious fireball, widened the frame of imagination. If fragments of other systems are already here, then every observation of dust, rock, or ice might contain more than local history. It might be a line in a foreign script, a fragment of a story from a star we cannot name. Thus, the quiet archive of possible interstellar objects grows not only Oumuamua, not only 3I, Atlas, but others hinted at in old data, in meteor trails, in whispers of light recorded long before we knew to look for such things. The question is no longer if there are more, but how many have already come and gone, unrecognized, in the vast and silent procession across our sky. With the arrival of 3I, Atlas, and the whispers of other possible interstellar bodies hidden in the data, the picture of our solar system began to change. Once thought of as a quiet enclave, a single star with its planets and comets, confined by invisible walls of gravity, it now appeared porous, vulnerable, and far busier than we had dared to believe. The question was no longer whether interstellar visitors exist, but how many are crossing our space at any given moment. Astrophysicists recalculated. Based on 2 confirmed detections in just a few years, the statistical likelihood suggested that thousands, perhaps millions, of such objects are drifting through the Milky Way, with countless currently sliding past unnoticed. They are faint, most no larger than city blocks or mountain ridges, and their light is swallowed by the darkness long before our telescopes can catch it. Yet their presence cannot be denied. They are here. They always have been. This realization painted the galaxy as a far more crowded place. If each star system ejects debris during its violent youth, fragments from collisions, comets cast outward by gas giants, asteroids jolted loose by stellar tides, then the space between stars must be saturated with wanderers. Our solar system, far from being a walled garden, is more like an open plaza, with doors on every side and strangers passing through at every hour. For humanity, there was awe in this vision. Each interstellar visitor is a story written under a different sun. Their chemistry carries the imprint of alien kitchens, where elements mixed in ratios unlike our own. Their structures tell of temperatures, pressures, and catastrophes in places we cannot see. Each shard of rock and ice is not just a physical traveler, but a fragment of memory from worlds scattered across the spiral arms of the Milky Way. But alongside wonder came unease. If the galaxy is this crowded with interstellar debris, what unseen dangers glide silently past our orbit? Most are harmless, distant, drifting through the outer solar system with no more consequence than a ship glimpsed on the horizon. Yet the possibility of collision remains. An interstellar rock, moving at tens of kilometers per second, carries an energy far greater than local asteroids of the same size. The odds are small, but in cosmic timescales, small odds become inevitabilities. This tension between beauty and fear, between awe and vulnerability, now shapes the way astronomers think about our place in the universe. We are not a solitary island. We are not a protected cradle. We are a crossroads, and the galaxy is busy with traffic. 3I. Atlas reminded us of this truth. It was not alone, and neither are we. The emptiness of interstellar space is an illusion. It is filled with fragments of creation, drifting testimonies to the violence and vitality of countless distant systems. The question is no longer whether we will meet another, but when, and whether, when the next one arrives, we will be ready to greet it not just as a curiosity, but as kin, a shard of the same universe that gave rise to us. When 3I, Atlas drifted into the focus of spectrographs, it carried with it the faintest of voices. Light fractured into color, each line and dip a clue to its chemical soul. Astronomers peered into those rainbows with the intensity of archaeologists brushing dust from a shard of pottery, for in those delicate spectra lay the first tangible hints of its birthplace. The fingerprints were subtle but unmistakable. Cyanogen, carbon monoxide, diatomic carbon, the same gases released by comets of our own solar system, glimmered in its halo. Yet their relative strengths were different. Their balance shifted. The ratios of carbon compounds suggested a chemistry sculpted under conditions not quite like those of our sun's nursery. In this alien comet, water still sublimated, but it mingled with exotic traces that whispered of colder birthplaces, of a disk more saturated with volatile ices than ours. Dust grains streaming from its coma told a parallel story. Polarization studies hinted at a different texture than the familiar silicate-rich dust of native comets. Perhaps these grains had crystallized under a weaker sun, or formed in a protoplanetary disk where metallicity was lower, where fewer heavy elements existed to seed the formation of rocky cores. If so, then 3I. Atlas was not only a traveler but also a record of a star's elemental abundance, a frozen archive of astrophysical conditions light-years away. It was a moment of profound intimacy. To study this faint visitor was to taste the flavor of another system's chemistry, to place our instruments against the heartbeat of an unknown sun. Each emission line was a syllable in an alien language, deciphered not by ear but by the bending of light itself. The analysis stirred speculation. If this was the composition of a mere shard, what would the parent system have been like? Did it orbit a star red and cool, where volatile ices were abundant? Or a young, tumultuous system where giant planets stirred the disk into chaos, scattering frozen bodies outward? Some even suggested that 3I, Atlas's chemistry, might indicate a birthplace in the crowded nurseries of the Orion Arm, where stars are born in dense clusters and their debris fields overlap. The philosophical undertone was unavoidable. Here, in a comet's breath, was proof that the universe is diverse even at the level of dust and ice. Our solar system is not a universal template, but one variation among countless chemical symphonies. Each interstellar object, if studied deeply enough, could act as a messenger, carrying in its spectral lines a postcard from another world we will never see. And yet, the opportunity was fleeting. As 3I, Atlas sped away from the sun, its activity waned, its outgassing slowed, and the spectral lines dimmed. Like a voice fading into the distance, its chemical song grew quiet. Astronomers recorded what they could, aware that no second chance would come. Still, what they gathered was enough to remind humanity of a profound truth. Even in the smallest fragment of ice, carried uninvited across the gulf of interstellar dark, lies evidence of entire worlds beyond our sight. And though the details blur as the traveler departs, the fact of its difference remains, etched in the faint glimmers of its light. The behavior of 3I, Atlas, carried echoes of something hauntingly familiar. Comets born under our own Sunday. As it neared perihelion, sunlight warmed its frozen surface, awakening jets of gas that spread outward into a diffuse coma. A faint tail of dust unfurled behind it, curling in the solar wind. To the telescopes that watched, it seemed almost ordinary, an icy wanderer stirred from slumber by the warmth of a star. Yet, in its ordinariness lay its strangeness. This was a ghost of comets, but one that belonged to no family, no cycle, no return. In our solar system, comets are ancient relics, frozen remnants of planetary birth. They dwell in the Kuiper belt and the Oort cloud, vast reservoirs at the edges of sunlight. Occasionally, gravity sends one plunging inward, where it flares to life before retreating back to its frozen exile. Each comet here is bound by loyalty to the Sunday. But 3I, Atlas, was different. Its bond was not to our star. It was a refugee from a foreign system, an orphan comet with no returning orbit, destined to flare once and then vanish forever. This difference unsettled astronomers. For if interstellar comets are not rare, then every planetary system is bleeding its own icy corpses into the galaxy. The Oort clouds of other stars must be porous, constantly losing fragments into interstellar night. The Milky Way becomes not a collection of isolated systems, but a single vast exchange where comets drift like dandelion seeds on the winds of gravity. The chemistry of 3I, Atlas's coma, reinforced the link. Its cyanogen and carbon monoxide emissions resembled those of our native comets, but with variations ratios slightly skewed, fingerprints slightly altered. It was as if one could see the same melody played in a different key. The universality of cometary behavior became clear. Across stars, ice and dust obey the same physics, responding to warmth with a brief, luminous exhalation. Yet in the details, the individuality of its origin whispered through. Philosophers of science lingered on the metaphor. A comet is a grave marker, a shard of planetary formation preserved in cold storage. To see one from another system is to glimpse a funeral held light years away. Each flare of gas is a message. This is how my world was born and how it broke. Some researchers speculated further. Might interstellar comets like 3I, Atlas be carriers of more than ice and dust? Could they harbor complex organic molecules, perhaps even precursors of life, ejected from their home systems and scattered across the galaxy? If so, then comets are not just ghosts of planetary systems, but seeds as well, drifting in endless dispersal. The idea of panspermia, life sown between stars by wandering debris, suddenly seemed less abstract. In the pale light of its coma, humanity was offered a strange reflection. 3I, Atlas looked familiar, acted familiar, and yet it was alien, a mirror showing both the sameness and the strangeness of the cosmos. It reminded us that our sun is not unique, our comets not singular, our world not insulated. We live in a galaxy of comets, ghosts forever passing through, each one carrying a story too vast for us to hear in full. As 3I, Atlas slipped further into the darkness. Its spectral traces grew thin, its tail faded, and its ghostly image dwindled. But the lesson remained. Comets are not confined to home. They wander, they flee, and in their wandering, they tell us that the galaxy itself is restless, scattering fragments of memory through the silence between stars. One of the most unnerving traits of interstellar visitors is their sheer velocity. 3I, Atlas arrived not at the leisurely speeds of comets nurtured within the sun's grasp, but at a pace that spoke of exile. Its measured speed, nearly 30 kilometers per second relative to the sun, placed it firmly beyond the reach of capture. Like a stone flung by a giant's hand, its trajectory was irreversible, cutting across the solar system in a brief arc before returning to the dark ocean between stars. For planetary scientists, velocity is more than a number, it is biography. High speed betrays a violent origin. In a planetary system, to reach escape velocity requires gravitational upheaval, a close brush with a gas giant, a collision that ejects fragments into space, or a stellar encounter that perturbs outer clouds. Every kilometer per second of excess speed tells of ancient chaos, of systems tearing at their own edges. 3I. Atlas carried this story in silence, its velocity a fossilized scream from its birthplace. Its indifference to gravity was a striking contrast to the familiar ballet of our solar system. Local comets linger, bend, return, but 3I. Atlas surged through with too much momentum to be tamed. It brushed past Jupiter's pull without pause, skimmed near the Sun only to be deflected by a shallow curve, and then pressed outward, unbound. The solar system was not its home but a brief corridor, one stop in an infinite procession. This speed carried implications beyond its own story. For Earth, it underscored a sobering truth. An interstellar object of sufficient size, on a collision course, would strike with energies far beyond what humanity has modeled from native asteroids. Its velocity would magnify its force, multiplying destruction. Though the odds are vanishingly small, the possibility is written in physics, and with time, small odds become certainties. Yet speed also carried promise. A fragment moving so swiftly across the galaxy could act as a courier. If bound within it are complex molecules, they may be carried vast distances from one system to another in spans of time that dwarf civilizations. It is possible to imagine that the seeds of life ride on such exiles, scattered across the spiral arms by collisions and expulsions, ferrying chemistry from world to world. Astronomers reflected on the paradox. Velocity makes these objects unreachable, yet also turns them into messengers. We cannot intercept them easily, cannot capture them for deep study, but their very motion proves the interconnectedness of the galaxy. They are the restless blood cells of a greater body, circulating between stars, carrying fragments of elemental memory. When telescopes tracked 3I, Atlas across the night sky, its position shifting rapidly against the constellations, it felt like watching a stranger pass through a crowded street without slowing, eyes fixed on a horizon we cannot see. Its pace was alien to us, its time scale incomprehensible. Yet, in its motion, we sensed the pulse of the galaxy itself, fast, relentless, and eternal. The moment two interstellar objects were confirmed, the narrative of improbability fractured. Oumuamua had been a solitary wonder, an object so strange that it could be rationalized as a once-in-a-lifetime event. But 3I, Atlas's passage only a short time later, changed everything. Two sightings, separated by only a handful of years, forced scientists to abandon the comfort of rarity. This was no anomaly. It was the outline of a pattern. Probability had shifted. If even one interstellar object could be detected by our relatively young survey networks, the odds of finding another should have been minuscule unless such visitors were far more common than expected. And yet, there it was. Two foreign bodies cutting across our sky, their trajectories unbound, their histories written in alien systems. It was enough to reframe the galaxy itself, not as a scatter of isolated suns, but as a restless ocean exchanging fragments in every direction. Patterns hold power. Once a single event becomes two, the human mind begins to search for rhythm, for repetition. Scientists recalculated the density of interstellar objects drifting through the Milky Way. The numbers leapt higher than conservative estimates had allowed. If we had spotted two so quickly, then billions must wander unseen, threading through star systems at every moment. The solar system is not an isolated stage, it is a corridor, and the doors are always open. The unsettling part of the pattern was not only its abundance, but its implication for permanence. If such objects are common, then they have likely been passing through our skies for eons, long before telescopes existed to notice them. Earth's past may have witnessed countless interstellar fragments slipping through silently, some perhaps colliding with the atmosphere, their presence erased before our species could record it. What we see now is only the beginning of recognition, not of the phenomenon itself. Oumuamua and 3I, Atlas, when seen together, form a pair of bookends, one dark and tumbling, one bright and cometary. Different in character, yet united by origin. Together, they hint at diversity among interstellar wanderers, and by extension, the diversity of the systems that cast them out. The pattern is not merely numerical, it is qualitative. These objects are not all the same. They carry with them the unique signatures of their parent systems, each one a fingerprint from a star we may never visit. The leap from 1 to 2 may seem small, but in cosmic reasoning, it is seismic. It transforms the improbable into the inevitable. 2 sightings are enough to predict the next, and the next after that. The pattern forces a redefinition of what the night sky represents. Not a sealed dome, but a permeable expanse where the borders of star systems blur and overlap. And so, with the passage of 3I, Atlas, humanity entered a new era of expectation. No longer do we wait for a fluke, we wait for the next messenger. The rhythm has begun, and the silence of space feels less empty, more like a corridor where footsteps echo just beyond our hearing. Among the more audacious ideas born from the study of interstellar wanderers was this: could they serve as unexpected probes of dark matter, the invisible scaffolding that outweighs ordinary matter in the cosmos? For decades, physicists have searched for ways to glimpse this hidden substance. Galaxies rotate too quickly for visible mass alone to hold them together. Something unseen exerts gravity's pull. Yet every experiment to detect dark matter directly has returned silence. Perhaps, some suggested, interstellar visitors could carry hints of its presence. The logic was subtle but intriguing. Objects like 3I, Atlas, have drifted through the galaxy for millions, even billions, of years. In that time, they have wandered not only past stars but through regions where dark matter density is thought to vary. If this invisible medium interacts in even the faintest way with normal matter, then fragments like comets or asteroids might bear those signatures: slight anomalies in trajectory, unexplained heating, or patterns in their distribution. Each interstellar rock could be, unknowingly, a detector. Oumuamua itself sparked speculation when its acceleration could not be fully explained by conventional outgassing. Could such deviations hint at unseen forces, perhaps gravitational nudges, not only from planets and stars, but also from the hidden halo of dark matter surrounding the Milky Way? Mainstream science leaned toward more mundane answers, but the question remained alive. Interstellar objects travel roads invisible to us, and along those roads may lie clues to the galaxy's unseen mass. Some theorists imagined even deeper connections. If the Milky Way's dark matter halo is laced with clumps or filaments, interstellar debris might be subtly concentrated or dispersed along those structures. To track their flow is to map, indirectly, the skeleton of the cosmos. Each foreign comet could then serve as a tracer particle, its journey a visible strand woven into the invisible web of matter. The idea was both thrilling and unsettling. If true, then these objects are not only messengers of other star systems, but also cartographers of the galaxy's hidden architecture. To study them is to trace the outline of the unseen. Every arrival at our doorstep would be more than a curiosity. It would be a gift of data, a chance to feel the contours of a reality that still lies beyond comprehension. Philosophically, the link is almost poetic. Dark matter has always been the great absence, a gravitational whisper without a face. Interstellar objects are the opposite, tangible, icy bodies that we can see and measure, but whose origins lie in absent systems far away, forever out of reach. Both are reminders of how much of the universe resists direct grasp. Both are puzzles defined by distance and invisibility. As telescopes record each new wanderer, scientists are not only collecting snapshots of alien systems but also, perhaps, listening for the subtle signatures of the unseen. If dark matter sculpts the galaxy, then interstellar debris may be the faint chalk lines that reveal its shape. And 3I, Atlas, like Oumuamua before it, may be more than an orphan comet. It may be a silent witness to the forces that hold the universe together. As astronomers traced the journey of 3I, Atlas, another layer of speculation unfolded. Perhaps its path was not entirely random. The Milky Way is not a still tableau, but a dynamic ocean of gravity, where stars drift, spiral arms ripple, and molecular clouds stir currents invisible to the eye. In such a sea, interstellar objects might not move chaotically at all, but along gravitational highways, routes carved by the complex interplay of stellar encounters and galactic tides. Computer simulations began to suggest that the ejection of comets from young planetary systems was only the beginning of their voyage. Once cast free, these fragments were guided by the broader choreography of the galaxy. Passing stars could bend their paths, steering them like celestial waypoints. Massive molecular clouds, those great nurseries where new stars are born, could tug them into streams. Over millions of years, individual trajectories blurred into rivers of motion, threading between suns like invisible lanes of traffic. Perhaps Oumuamua and 3I, Atlas, were not isolated wanderers at all, but members of such streams, debris fields, shaped by long histories of stellar scattering. If so, then their arrival in our solar system was not pure coincidence, but the inevitable result of the solar system drifting through a region rich with interstellar fragments. Our star, orbiting the galactic center once every 230 million years, may regularly pass through such currents, stirring brief flurries of arrivals before moving onward into quieter space. This idea shifted the tone of the mystery. The visitors were no longer solitary exiles, but travelers in a larger procession, pieces of a cosmic migration that spans spiral arms. To watch one pass was to glimpse the edge of an unseen river, flowing ceaselessly through the galaxy. If we could chart enough of them, we might map those currents, learning not only where such objects come from, but also how the Milky Way itself breathes and circulates its matter. For scientists, the metaphor of highways carried practical implications. If interstellar debris truly clusters into streams, then targeted surveys could focus on regions of sky where encounters are most likely. Future missions might even wait, like fishermen at crossroads, poised to intercept the next wanderer when it enters our net of telescopes. Philosophically, the notion of galactic highways was deeply resonant. Humanity has long traveled along rivers, trade winds, and caravan routes, guided by natural pathways that connect distant lands. Now we discover that the galaxy, too, has its corridors, routes that carry not merchants or pilgrims, but icy fragments of forgotten worlds. To find 3I, Atlas, upon such a road is to recognize ourselves within a larger order, a reminder that the same laws guiding human journeys also shape the migrations of stone and ice across billions of years. In the slow, patient drift of 3I, Atlas, we glimpsed more than a solitary path. We glimpsed the possibility of a greater flow, the hidden rivers of the Milky Way, carrying the debris of countless stars across the spiral arms, until, for a brief moment, one fragment brushed against the light of our own Sunday. Behind the drama of sudden discoveries lies the quiet labor of the sky's sentinels, surveys designed not for spectacle but for vigilance. The detection of Oumuamua and 3I, Atlas, was not luck alone. It was the fruit of decades spent building instruments capable of sweeping vast regions of the heavens with relentless precision. Among these, the Pan-STARRS array in Hawaii and the Atlas system, whose very mission is to scan for potentially hazardous asteroids, stand as watchtowers on the frontier of human perception. Pan-STARRS was the first to glimpse Oumuamua, its wide-field telescopes tracing faint moving specks across dense star fields. Atlas, designed to protect Earth by providing early warnings of incoming objects, recorded the motion of 3I, Atlas, a discovery that extended its mission beyond planetary defense into cosmic revelation. These were not singular instruments but part of a growing network of automated eyes, coordinated, tireless, and patient. Yet these tools, as sophisticated as they are, remain limited. Their sensitivity fades with distance. Their coverage is dictated by weather, by time zones, by the rotation of the Earth itself. Astronomers know that for every interstellar object caught, countless others pass unnoticed, too dim, too fleeting, slipping across the edges of our maps. The night sky is a vast sea, and our nets, though widening, still leave enormous gaps. The coming decade promises an expansion of vigilance. The Vera C. Rubin Observatory in Chile, with its legacy survey of space and time, LSST, is poised to revolutionize our vision. Night after night, it will scan the southern sky with unprecedented depth and breadth, capturing motion in faint objects that once would have escaped. Its data may reveal not one, but dozens of interstellar visitors each year, transforming singular anomalies into a catalogue of foreign bodies. These surveys represent more than technology. They are a shift in philosophy. Where once the heavens were observed piecemeal, targeted at the bright and obvious, now they are monitored systematically, every patch of sky recorded, archived, and compared. The cosmos is no longer glimpsed in fragments but surveilled in continuity, like a slow film unfolding frame by frame. For the scientists behind these projects, there is a quiet sense of awe. Each pixel captured could contain the faint trace of something unimaginable, a messenger from another star, a shard of galactic history. The discovery of 3I, Atlas, was not an end but a beginning, proof that the tools we build are finally sensitive enough to notice what has always been passing through. Philosophically, this quiet work echoes humanity's oldest instinct, the need to watch the horizon. Just as our ancestors scanned for approaching ships or migrating herds, we now scan the sky for visitors whose journeys began light years away. The act is the same: vigilance against surprise, hope for encounter, the need to see what comes before it is upon us. The surveys continue, night after night, their data streaming silently into servers where algorithms sift and flag. Somewhere in those millions of stars, the next faint traveler waits to be found. We will not know it until the software circles a single pixel and whispers, "Here is another." For all the triumphs of Pan-STARRS, Atlas, and the vigilant surveys that netted Oumuamua and 3I, Atlas, astronomers know this truth. The sky is still mostly invisible to us. Our instruments, no matter how advanced, are bound by thresholds of light, by the faintness of objects, by the narrow windows of observation carved out of weather and daylight. Between the images captured lies an ocean of silence where countless interstellar visitors may drift unseen. Most interstellar bodies are small, no larger than mountains, many no bigger than houses or boulders. Their surfaces reflect only a whisper of sunlight, and as they speed through space at tens of kilometers per second, their presence becomes nearly impossible to register until they are already near and often already gone. Even with the powerful reach of the Rubin Observatory's coming survey, the majority will slip past without witness, leaving no trace except in the gravitational arithmetic of the galaxy. Consider this: for every Oumuamua and 3I, Atlas, there may have been hundreds, perhaps thousands, of others that entered the solar system undetected. Before the rise of wide-field digital surveys, the odds of catching one were negligible. They would appear suddenly, faint and fast, and by the time telescopes were trained on them, they would already be vanishing into the dark. The night sky was never empty. Our blindness simply painted it that way. Even today, technological constraints shape the limits of our awareness. Cameras saturate on bright stars, washing out faint traces. Algorithms must distinguish genuine motion from noise. Telescopes cannot watch all directions at once. The Earth's rotation hides half the heavens from any single vantage. Clouds, atmospheric turbulence, and the moon's glare erase fragile signals. In these blind spots, countless travelers pass unrecorded. This invisibility is both humbling and haunting. Humanity has built machines capable of seeing galaxies at the edge of time, yet we can still miss a shard of rock sweeping silently past our own doorstep. The paradox stings. The nearer the object, the harder it often is to see. Proximity does not guarantee visibility. And so, astronomers look to the future with a kind of restless patience. More sensitive detectors, wider fields, and faster processing will improve our nets, but the ocean will always be vaster than our reach. Interstellar debris is a tide without end, and our observations will remain a sampling, never a census. Philosophically, this recognition carries weight. Humanity lives surrounded by mystery, not only in the deep past of the cosmos, but in the immediacy of the present. Objects from alien systems are likely passing near us right now, unseen, anonymous, indifferent. They do not wait for discovery. They simply drift, bearing with them histories we will never read. Perhaps that is the truest measure of the universe, not how much we see, but how much we fail to see. Each discovery, like 3I, Atlas, is not a conquest of knowledge, but a glimpse through a keyhole, a reminder of how much remains hidden in the dark. The blindness is permanent, but the glimpses are enough to remind us that the night sky is alive with strangers. With the passage of Oumuamua and 3I, Atlas, a quiet storm of speculation rose not from data alone, but from the imaginations of scientists and dreamers alike. The objects' strangeness, their indifference to capture, and their fleeting presence ignited questions that edged into the exotic. What if these wanderers were not merely fragments of rock and ice, but something more? Oumuamua, especially, lingered in debate. Its elongated shape, or was it flattened like a shard, defied easy categorization. Its peculiar acceleration, unaccompanied by visible outgassing, stirred whispers. Could it have been propelled by means we do not yet understand? Some theorists, most famously Avi Loeb, dared to suggest it might have been a technological relic, an abandoned probe, a fragment of alien engineering, perhaps even a light sail drifting through the galaxy. To mainstream astronomers, such ideas felt premature, even reckless. Yet the unease of Oumuamua's behavior kept the question alive. When 3I, Atlas, arrived, with its more conventional cometary tail, those wilder theories retreated somewhat. Here was an object that behaved as expected, gas streaming, dust scattering, its orbit explainable by physics we knew, yet even so, the conversation lingered. If one interstellar visitor could appear ordinary, another extraordinary, what spectrum of possibilities remains hidden among the unseen? Could some visitors be artifacts, lost machines from civilizations long vanished? Could interstellar space be seeded not only with nature's debris, but with the remnants of intention? Science treads carefully in such territory. Evidence must be weighed, skepticism must stand guard, but the human imagination cannot help itself. For millennia, we have looked at the stars and wondered who else might dwell there. Now, with physical fragments from other systems slipping into our skies, the question grows sharper. Is every shard we see a child of chaos? Or could one, someday, prove to be the footprint of intelligence? The exotic hypotheses reveal less about the objects themselves than about our longing. They expose humanity's hunger to not be alone, to find evidence that the universe has spoken before us. Each interstellar visitor is a mirror reflecting that yearning. In its silence, we hear our own questions echo. Even as mainstream astrophysics grounds itself in natural explanations, gravitational ejections, volatile ices, molecular spectra, the exotic hovers at the edges, whispering possibilities. And perhaps this is as it should be. The history of science is not only written in measurements, but also in the daring of speculation. To imagine that one of these wanderers could be more than stone is to keep alive the openness of inquiry, the refusal to let certainty blind us. For now, 3I, Atlas remains a comet, a natural shard of another world. But the next one may behave differently, tumbling in ways we cannot explain, reflecting light like metal, or accelerating with no plume of gas. When it comes, the boundary between natural and artificial may blur. Until then, these hypotheses remain both fringe and fascinating, a reminder that the universe is vast enough to hold both dust and dreams. The speculation that swirled around Oumuamua and 3I, Atlas, whether they were natural or artificial, demanded a response. Science, grounded in skepticism, moves cautiously, pushing back against extraordinary claims until evidence is undeniable. And so, the mainstream view reasserted itself with quiet firmness. These were fragments of nature, not machines of intention. Astronomers returned to the data, weighing every anomaly against the discipline of physics. Oumuamua's peculiar acceleration, once touted as inexplicable, was examined again. Could outgassing, though invisible to our instruments, account for the slight push? A tiny jet of gas, perhaps too faint or brief to be captured, might have nudged the body away from the Sunday. Models were refined, error margins scrutinized, and though mysteries lingered, plausible natural mechanisms emerged. 3I, Atlas, with its obvious cometary activity, reinforced that caution. Not all enigmas require alien hands. This pushback was not born of dismissal, but of necessity. To leap too quickly to extraordinary conclusions would erode the integrity of science. Better to probe anomalies with patience, to assume nature's strangeness before proposing artifice. In this measured restraint lies the strength of scientific inquiry, its willingness to be surprised, but not seduced. And yet, even as exotic interpretations were softened, scientists did not turn away from the unknown. Instead, they redirected focus toward testing. More precise instruments, faster surveys, and missions capable of rendezvous with future visitors were proposed. If another interstellar object appeared, the goal would be to meet it not only with telescopes, but perhaps with spacecraft, to taste its dust directly, to remove ambiguity with physical samples. The debate itself was valuable. It revealed how the scientific process balances wonder with rigor, how it tolerates speculation while anchoring itself in evidence. The exotic theories sparked funding discussions, public attention, and deeper analysis of orbital mechanics. They widened the circle of inquiry. Even if the eventual conclusions leaned toward natural explanations, philosophically, the moment revealed something about humanity. Our reflex is to imagine intelligence behind the unfamiliar, to see design in the strange. But the cosmos is vast enough that nature alone can astonish us. A shard of ice, ejected millions of years ago from a collapsing disk, can provoke as much awe as any artifact. In its silence, in its indifferent passage, it carries a mystery that no human hand could have crafted. Science pushes back not to erase the poetry of speculation, but to preserve its integrity. By resisting premature conclusions, it ensures that when the evidence for something truly extraordinary arrives, it will be recognized for what it is. Until then, interstellar wanderers like 3I, Atlas remind us that nature's imagination exceeds our own, that the galaxy can craft wonders without intention, shaping stones and comets into messengers that need no engineer. As the debates settled into more grounded territory, scientists began to place interstellar objects within a larger context, the life and death of planetary systems. In many ways, 3I, Atlas was not an anomaly, but an emissary, carrying the fingerprints of processes that shape worlds everywhere. To understand it was to glimpse the forces that sculpt not only our solar system, but all systems born under the Milky Way's spiraling arms. Exoplanet research had already revealed a universe of chaos. Thousands of worlds had been discovered orbiting distant suns, gas giants skimming perilously close to their stars, Earth-sized planets locked in tidal embrace, barren giants flung into eccentric paths. From these discoveries, a truth emerged. Planetary systems are volatile, sculpted by migration, scattering, and gravitational conflict. Giants move inward, pushing smaller bodies aside. Collisions smash worlds to rubble. Fragments are hurled outward in violent exodus. It is in these exoduses that objects like 3I, Atlas, are born. A young planetary system acts like a slingshot, its giants scattering icy bodies to the fringes. Some settle into distant reservoirs like our own Oort cloud. Others gain just enough speed to cross the threshold into interstellar space, leaving their parent stars forever. Over billions of years, these expulsions accumulate, filling the galaxy with a ceaseless rain of fragments. Seen in this light, 3I, Atlas was not an exception but a rule. Every star system likely contributes to this galactic tide. Each interstellar traveler is a relic of planetary struggle, a shard of chaos wandering without anchor. To glimpse one in our skies is to watch a universal process in miniature, the echo of distant planets shaping themselves through violence. The connection deepens when one considers the chemistry of these objects. Comets preserve the primordial material of their birth systems, the frozen gases and dust from which planets emerge. To study 3I, Atlas was to hold up a mirror to our own solar system's infancy, to compare its ingredients with those of a stranger. Did its star-forming disk contain the same building blocks of water, carbon, and silicates? Or did it bear signatures alien to us, ratios that suggest worlds utterly unlike Earth? Philosophically, this recognition is humbling. We often imagine our solar system as unique, its comets and asteroids as artifacts of our singular history. Yet 3I, Atlas, tells us otherwise. It is proof that what happened here, the scattering, the exiling of frozen relics, happens everywhere. The galaxy is littered with the memories of planetary births and deaths, and our system is only one among billions contributing to this silent exchange. The lesson is twofold. We are not alone in our violence, nor in our creativity. Just as our own system bleeds fragments into interstellar space, so too do others. In the endless dark, these exiles drift past one another, silent testimonies to the universality of creation and destruction. 3I, Atlas, then, was not only a comet but a philosopher's stone, a fragment that reminded us that planetary systems are not static, but alive, restless, shedding and reshaping. To follow its path was to glimpse not only a visitor from afar, but the shared destiny of all worlds. As the catalogue of interstellar visitors slowly began to form, two confirmed, several candidates, and countless suspected, a deeper speculation emerged. Perhaps these fragments are more than just stray debris. Perhaps they are messengers of environments utterly unlike our own, stones shaped under the light of suns with chemistries foreign to us, carrying within their mineral lattices the imprint of places we may never reach. Astronomers studying the diversity of exoplanets knew that the Milky Way is not uniform. Some stars are rich in heavy elements, birthing rocky worlds dense with metals. Others are poor, yielding planets swathed in gas and ice. In this cosmic diversity, the comets and asteroids expelled into interstellar space must likewise differ. Their ratios of carbon to oxygen, the isotopes frozen in their ices, even the crystalline structures of their dust, all these bear the fingerprints of alien nurseries. To catch one of these objects is to hold, briefly, a piece of another world's geology. 3I. Atlas may have formed near a dim red dwarf, in a disk colder than anything in our solar system. Or it may have emerged from a massive star's chaotic birth cluster, its chemistry imprinted with the violence of stellar winds. Oumuamua, in its enigmatic strangeness, could be the child of an even more exotic environment, a shard, fractured in conditions we struggle to imagine. From this arose the idea of the multiverse of stones, that the Milky Way is not only a gallery of stars, but a circulating archive of planetary relics. Each interstellar fragment is a page torn from a different story, drifting through space until chance delivers it to another reader. To intercept one is to borrow, for a moment, another star's memory. Philosophers of science found poetry in this. We are accustomed to learning about the universe through light photons crossing vast distances, carrying the signatures of distant stars. But interstellar objects are not light. They are matter itself, material couriers. They are the galaxy's parcels, physical pieces of elsewhere, wandering between homes. If starlight is information, then these objects are evidence hard, tangible, undeniable. The speculation extended even further. Could such wanderers not only reveal chemistry, but also entirely novel physics? If some fragments condensed in environments under different pressures, or formed in disks with unusual radiation profiles, they might carry structures unlike anything seen in our laboratories. To hold a fragment of such a body would be to touch matter shaped by conditions utterly foreign to our world. Though we have not yet intercepted one with a spacecraft, the thought lingers like an invitation. The next visitor may not only confirm what we know, but show us what we have never dreamed. The diversity of stones is the diversity of the galaxy itself, scattered and drifting in endless circulation. 3I, Atlas, fleeting and faint, was only the beginning of this realization. It told us that the Milky Way is not a void separating worlds, but a network of exchange, a library without shelves, where the books drift freely and the stories arrive unbidden. If interstellar fragments carry the chemistry of alien suns, could they also carry something deeper, molecules that hint at the origins of life itself? The possibility of panspermia life, seeded between stars by wandering debris, found new resonance in the age of Oumuamua and 3I, Atlas. Suddenly, the concept was not confined to speculation. Here were real couriers, real stones proven to travel between systems, their frozen interiors shielded from radiation for millions of years. Comets within our own solar system already bear the signatures of life's ingredients. The Rosetta mission to Comet 67P, Churyumov-Gerasimenko, revealed complex organic molecules, carbon chains, amino acid precursors, sugars that echo the recipes written in Earth's earliest rocks. If such chemistry exists in our backyard, then it surely exists in comets abroad, and when fragments are ejected into interstellar space, they carry these organics outward like spores on the wind. 3I, Atlas, with its cometary halo, rich in carbon monoxide and cyanogen, reminded scientists of this possibility. Beneath its crust, shielded from cosmic rays, could lie more fragile molecules, perhaps chains of carbon assembled in the frozen dark. Whether these molecules are seeds or simply byproducts, their dispersal across the galaxy would weave a chemical continuity. the same ingredients that sparked life on Earth drifting through alien systems, waiting for new worlds to receive them. The concept is both beautiful and haunting. Life on Earth may not be wholly local. It may be part of a galactic inheritance, its raw materials spread across the spiral arms by countless wandering comets. In this view, the Milky Way itself is a vast laboratory, with stars as burners and comets as test tubes, mixing and scattering ingredients until, somewhere, chemistry tips into biology. Philosophically, the arrival of interstellar objects sharpens the question of origins. Did Earth's life arise from ingredients seeded here at birth, or were we enriched by gifts from afar, silent couriers like 3I, Atlas, that passed through before we had eyes to notice them? If panspermia is real, then every interstellar visitor is not just a relic but a potential ancestor, carrying in its frozen interior the whispers of life's cosmic continuity. The notion carries with it humility. If life's chemistry is scattered so widely, then Earth is not singular, not chosen, but one node in a vast network of possibility. Life may not be an exception but an expectation, arising wherever conditions allow. Each visitor, then, is a reminder that we share our galaxy not only with stars and dust, but with the ingredients of vitality itself. As 3I, Atlas faded into the dark, the question remained unresolved, but more urgent. Are these icy exiles simply the debris of chaos, or are they emissaries of something far greater, a living chemistry that binds the galaxy together? The beauty of interstellar wanderers is tempered by a sobering truth. Speed makes them not only elusive but dangerous. Objects like 3I, Atlas, cut through space at tens of kilometers per second velocities, far greater than most native asteroids or comets. Were such a body to collide with Earth, the impact would release energy orders of magnitude beyond anything humanity has ever faced. The likelihood is low, yet the possibility cannot be erased. Our planet bears the scars of collisions. The Chicxulub impactor, 66 million years ago, ended the reign of the dinosaurs and reshaped life's trajectory. That object was homegrown, an asteroid or comet born under the Sunday. An interstellar impactor, arriving at higher speed, would strike with far greater force. Even a fragment only a few hundred meters across could devastate continents. A body 1 kilometer wide could undo civilization itself. Astronomers do not dwell on this scenario lightly, but the math insists on its inclusion. If interstellar objects are more common than once thought, then their orbits occasionally must intersect Earth's path. Over millions of years, chance becomes certainty. The challenge lies in scale. While native comets return on predictable cycles, interstellar visitors arrive unannounced, their arcs fleeting, their windows of detection perilously small. By the time one is seen, it may already be too late. This threat is not reason for despair, but for vigilance. Surveys like Atlas were designed to protect Earth by detecting hazardous asteroids early enough to intervene. Extending this vigilance to interstellar bodies is more daunting, but not impossible. Future observatories may scan deeper, catch them sooner, perhaps even calculate their probabilities of impact long before danger approaches. Humanity's first line of defense lies in awareness. And yet, the philosophical tension remains. Each interstellar visitor inspires awe as a messenger from another star. To imagine such a body as threat feels almost sacrilegious, as if beauty itself might strike us down. But this duality is written into the cosmos. The same processes that give us fragments to study also fling them as potential weapons. Creation and destruction are entwined. The very stones that carry the seeds of life may also carry extinction. To contemplate this is to confront the fragility of our species. We drift through the galaxy exposed, our world unshielded, our history tied to the whims of cosmic chance. Each interstellar comet that sweeps past safely is a reminder of how narrow the margins are, how much of our existence rests on luck. And yet, there is resilience in awareness. The more we learn, the more we see, the better we prepare. 3i. Atlas did not come near Earth, but its presence forced us to acknowledge the possibility. It taught us that the heavens are not empty. They are alive, restless, filled with fragments of other worlds. Each one could be a teacher or a destroyer. Each one carries both promise and peril. If 3i, Atlas and Oumuamua were the first whispers, then the years ahead may bring a chorus. The expanding watch list of interstellar candidates has become a frontier of modern astronomy, and with each new telescope or survey, the probability of catching the next visitor grows. What was once unimaginable, discovering two such objects within a handful of years, has now become expectation. The sky is no longer silent, it is being watched with new intent. At the forefront are the great surveys. The Vera C. Rubin Observatory in Chile, with its legacy survey of space and time, promises to capture the faint motions of millions of small bodies, some of which will not belong to our Sunday. Its vast camera, the largest ever built for astronomy, will sweep the sky night after night, stitching together a living archive. For the first time, humanity may begin building not just anecdotes but a catalogue of interstellar wanderers. Complementing Rubin are missions in space. The European Space Agency's Comet Interceptor, slated for launch in the late 2022, is designed to wait in readiness at a gravitational waypoint, prepared to dart toward any newly discovered comet, including, potentially, one from beyond the stars. Should fate align, it could become the first spacecraft to encounter an interstellar visitor directly, tasting its dust, measuring its chemistry, and returning with evidence beyond doubt. Other proposals sketch even more daring futures. Probes launched on fast trajectories, capable of intercepting the next Oumuamua-like object as it blazes through. Concepts such as breakthrough starshot, originally envisioned to send light sails to nearby stars, are being reimagined as potential interceptors for interstellar debris. These missions, still theoretical, embody a new ambition to transform fleeting glimpses into direct contact. The expanding watch list is not merely technological but philosophical. To prepare for visitors is to acknowledge them as part of our cosmic environment, as real and recurring as eclipses or meteor showers. It reframes our solar system from isolation to intersection, a place where other worlds leave their signatures. Each detection adds urgency. Astronomers now monitor streams of data with fresh eyes, searching for the telltale curve of a hyperbolic orbit, the unmistakable signal of an unbound traveler. Alerts ripple quickly through global networks. Telescopes across continents swivel, data pours in, every moment precious before the object fades. The process has become a ritual, a choreography of vigilance. 3i. Atlas may be gone, but it left behind a legacy, the certainty that others will follow. Our role is no longer passive wonder, but active pursuit. The watch list grows longer, the tools sharper, the questions deeper. In every faint trace of moving light, there may lie the next messenger, the next shard of a world not our own. The era of isolated surprises is over. The era of anticipation has begun. If the watch lists and surveys represent humanity's vigilance, then the next step is bolder still, to reach out and touch an interstellar visitor. For astronomers, telescopes can whisper chemistry and motion, but they cannot replace the intimacy of contact. To hold dust from another star system in our laboratories would be to collapse distances measured in light years into a vial no larger than a hand. The idea of cosmic archaeology has gained momentum. Just as archaeologists unearth shards of pottery to reconstruct vanished cultures, scientists dream of capturing shards of interstellar debris to reconstruct vanished worlds. Space agencies have begun to sketch the outlines of such missions. The Comet Interceptor, waiting patiently at the Sun-Earth L2 point, is one prototype, an ambush mission, ready to sprint toward a newly discovered target. If fortune aligns, it may be the first to confront an interstellar body head-on, but more ambitious concepts stir in white papers and research proposals. One is the notion of fast interceptors, spacecraft launched in readiness, equipped with sails or advanced propulsion, capable of rapid acceleration to chase down incoming visitors. Another imagines deploying swarms of small probes, cheap, numerous, disposable, that could surround a passing object, sampling gas and dust before it vanishes into darkness. Each idea carries urgency, for the window of opportunity is brief. Once such a body is detected, the countdown begins. Months, sometimes only weeks, before it slips beyond reach. The motivations are profound. A single grain of dust, collected from the coma of a foreign comet, could reveal isotope ratios unknown in our solar system, frozen fingerprints of a different sun's nursery. A captured fragment could confirm whether organic molecules, the precursors of life, are common across the galaxy. To study such material would be to compare the recipes of worlds, to see whether life's ingredients are a local accident or a galactic refrain. There is also the dream of sample return, though the engineering challenges are immense. How to rendezvous with an object traveling at tens of kilometers per second, scoop matter from its surface, and return it across years of interstellar exile. Yet these challenges do not silence ambition, they sharpen it. Humanity has already returned grains from comets and asteroids. The leap to interstellar material feels less like fantasy and more like inevitability. Philosophically, the pursuit is rich with symbolism. For millennia, humans have reached outward stone tools, ships, rockets, always seeking contact with what lies beyond. To intercept an interstellar fragment is to extend that lineage into the galactic scale. It is to refuse passivity, to transform chance encounter into deliberate communion. 3i. Atlas reminded us of what slips through our fingers when we do nothing. The future will not be content with watching from afar. The future demands touch. The story of 3i, Atlas, does not exist in isolation from the great frameworks of physics. Its passage across our skies reawakened the shadows of Einstein's legacy. For every interstellar object is a test of relativity written into stone. As it sped past the sun, its trajectory bent not into an ellipse of captivity, but into a shallow hyperbola, curved by gravity yet never bound. That curve was not guesswork. It was space-time itself revealing its structure. Einstein taught that mass warps space-time, and objects follow those curves like marbles rolling across a distorted fabric. The path of 3i, Atlas, was a demonstration of this principle on a galactic scale. Its speed and trajectory mapped the sun's invisible geometry. To chart its orbit was to measure the shape of space-time itself, curved but not closed. For a fleeting season, astronomers had in their grasp a probe from elsewhere, tracing with its own motion the contours of Einstein's equations. More subtly, its velocity evoked relativistic imagination. At 30 kilometers per second, 3i, Atlas, was far from the domain where time dilates and lengths contract. Yet still, it reminded physicists of the deeper truth. Speed is relative. To us, it was a comet hurtling too fast to stay. To itself, time passed just as gently as always. Every interstellar traveler carries with it the reminder that motion is not absolute. Its story is written differently from every vantage. Relativity also deepened the mystery of origins. The galaxy is a stage where massive stars explode as supernovae, neutron stars drift, and black holes lurk. Each of these bends space-time with an intensity the sun cannot match. What if 3i, Atlas, had once skirted near such an abyss, its orbit twisted by invisible hands? What if its current trajectory is not merely the product of ejection, but of encounters with warped space-time along the way? Every interstellar path may carry echoes of relativity's grandeur. The reflection stretched further still. Einstein himself pondered the unity of nature, the harmony underlying chaos. In 3I, Atlas, we find that harmony written quietly, a shard from a distant world moving exactly as the laws of relativity predict, even though its birthplace is unknown, even though its exile is eternal. It obeys the same fabric of physics that governs our own planets and moons. This sameness is profound. It means that across billions of stars and trillions of worlds, the rules are one. And yet, within that sameness lies difference. Its chemistry whispers of alien nurseries, its trajectory of violent scattering. The laws are universal, but the stories they generate are infinite. 3I, Atlas, was both a testament to relativity's permanence and a reminder of the galaxy's restlessness. Einstein's shadows stretched over its path, confirming that even wanderers obey the same invisible architecture, even as they carry evidence of worlds beyond our imagining. To watch it glide outward was to feel that duality, certainty and mystery, order and wonder. A comet from elsewhere, moving exactly as space-time dictates, yet carrying questions no equation alone can answer. If Einstein's framework defined the invisible stage on which 3I, Atlas, traveled, then Stephen Hawking's legacy offered the philosophical echo, a reminder that the universe is not only mechanical, but also profoundly mysterious, forever inviting deeper questions. Hawking's work, spanning black holes, singularities, and the nature of time, gave humanity a language for cosmic curiosity. To contemplate an interstellar wanderer through his lens is to feel both awe and unease, recognizing how much we know and how little we can ever claim to master. Hawking often described the cosmos as a place where boundaries dissolve, where beginnings and endings blur, where matter and energy trade identities, where information itself seems uncertain. 3I, Atlas embodied this spirit. It was not ours, yet for a brief moment it belonged to our sky. It had no beginning we could trace, no destination we could follow. It was evidence without context, a fragment cut from a story we will never fully read. Its presence was a paradox, concrete in its chemistry, yet unknowable in its origin. Black holes fascinated Hawking because they turned physics into philosophy. Interstellar objects do the same, in quieter ways. Their orbits remind us that permanence is an illusion. Nothing is truly bound forever, not even planets, not even suns. Given time, all systems shed their fragments, all bonds dissolve. 3I, Atlas, was the embodiment of that truth, a shard cast loose into the void, a traveler indifferent to our attempts to capture meaning from its silence. Hawking also speculated about extraterrestrial life warning, with characteristic irony that we should be cautious what we wish to find. Interstellar visitors sharpen that warning. If comets can cross star systems, so too could other messengers, some perhaps artificial, their intentions unreadable. 3I, Atlas was not such a craft, but it carried the shadow of that question. What if, one day, the object we track is not natural but deliberate? Hawking would remind us to weigh wonder with caution, imagination with humility. Philosophically, the presence of such wanderers aligns with Hawking's broader message that humanity is small, fragile, yet capable of greatness in its capacity to ask questions. We may never know the exact star from which 3I, Atlas, was flung, but in seeking, we honor the curiosity that defines us. Each interstellar visitor expands the horizon of mystery, forcing us to admit that our solar system is not self-contained, but part of a restless, interconnected galaxy. When Hawking spoke of knowing the mind of God, he was not invoking religion. but the yearning to glimpse the ultimate structure of reality. 3. Atlas offers a fragment of that structure, not in revelation, but in reminder. The laws are universal, the stories diverse, the questions endless. Its passage through our skies is a whisper of the infinite, a prompt to keep looking, keep asking, keep imagining. In the wake of its departure, we are left with Hawking's echo. The universe is not obligated to explain itself to us. It reveals itself in glimpses through black holes, through cosmic radiation, through wandering shards like 3I Atlas. Our task is not to demand answers, but to listen and to let the silence shape our wonder. Beyond the calculations and the physics, there lingers a quieter revelation, the way interstellar visitors like 3I Atlas mirror humanity itself. These objects are wanderers, cast adrift from the systems that birthed them, carrying fragments of history into places that will never know their beginnings. In them, we see not only alien chemistry, but also the reflection of our own condition, rooted, yet restless, forever reaching beyond the horizon. When 3I Atlas swept across the solar system, it reminded us that exile is a universal story. Planets scatter comets, stars shed fragments, galaxies themselves trade stars when they collide. Nothing in the cosmos remains fully bound. Even Earth is not eternal. One day, billions of years hence, it will be consumed by the sun or flung outward in galactic tides. In this sense, the interstellar visitor is kin, a traveler whose solitude mirrors our own fragile impermanence. Philosophically, the presence of such wanderers erodes the illusion of separateness. We imagine our solar system as self-contained, but its borders are porous, its history entangled with distant systems. If stones from alien suns can pass through our skies, then the galaxy is not a map of islands but a web, each thread tugging at another. Humanity, too, is part of this web, our origins tied to stars that exploded before the sun was born, our atoms scattered across cosmic time before finding shape in human form. There is an emotional intimacy in this recognition. To look at 3I Atlas through a telescope is to realize that we share more with it than with any myth of isolation. It is a fragment of elsewhere, but its elsewhere is also our own. The galaxy is a single organism, and every shard, every comet, every star, every person is part of its restless circulation. This intimacy sharpens our longing. We crave connection, to know that we are not alone in the silence. And so, when Oumuamua tumbled strangely, some leapt to imagine it as a probe. When 3I Atlas trailed a comet's veil, others whispered of seeds of life. Beneath every theory lies the same human impulse, the need to see ourselves reflected in the other, to find kinship even in ice and stone. The interstellar object thus becomes a mirror, not only of cosmic processes but of human yearning. In its indifference, it confronts us with our hunger for meaning. In its silence, it reveals the voices we project onto the stars. It is not alive, but it awakens the living within us, reminding us that our greatest discoveries are also our deepest questions. As 3I Atlas faded into darkness, humanity was left with a choice: to see it as a passing curiosity, or to recognize it as a reminder of our own place in the galaxy, a place defined not by isolation, but by connection. We too are wanderers, brief travelers through the corridors of time, carrying with us fragments of a story whose beginning and ending lie far beyond our sight. The departure of 3I Atlas returned the sky to silence. Its coma dissolved, its dust dispersed into invisibility, and telescopes, once fixed upon it, turned back to the regular cadence of planets and stars. Yet its absence carried as much weight as its presence. It left us with the awareness that our solar system is not sealed, that strangers pass through even when we are not looking, and that the night sky breathes with more life than our eyes can hold. In its wake, questions linger like after-images. How many such wanderers glide past us unnoticed? What secrets do they carry in their frozen cores? Do they bear the seeds of chemistry that may have kindled life elsewhere, or even here? And if exile is the fate of fragments from every star system, then is our galaxy less a wilderness and more a restless circulation of matter, exchanging pieces the way wines exchange seeds across fields? What struck most deeply was not the data, but the perspective. 3i Atlas was indifferent to us, yet in watching it, we felt a kinship. Its journey was proof that we are not alone, not in the comforting sense of neighbors who speak, but in the sobering sense of stones and ice crossing our sky from places we will never reach. Its indifference forced us to ask, what does it mean to live in such a porous universe, where the borders of systems blur and the familiar mingles constantly with the foreign? This mystery is not solved, it is ongoing. The watchtowers of our telescopes continue to sweep the heavens, waiting for the next messenger. The Rubin Observatory will see deeper. Comet Interceptor may meet one face to face, and beyond them lies the promise of missions that may one day bring back the dust of another sun, tangible in our hands. Until then, we remain watchers, listening for footsteps in the corridors of the galaxy. In the silence after its departure, one truth resounds. Interstellar visitors are not exceptions, but inevitabilities. They are the galaxy's reminders that everything is connected, that nothing remains bound forever, that exile and encounter are the rhythms of existence. And so, as we close the chapter of 3i, Atlas, we open another, the readiness to greet the next. Now the pacing slows. The comet is gone, and we are left beneath a quiet sky. The stars above appear still, yet we know now they are not. Between them drift shards of forgotten worlds, silent pilgrims on journeys too vast for our clocks. They come and go without pause, brushing through our solar system like shadows crossing a candle flame. There is comfort in this restlessness. It tells us that we are not isolated, not alone in emptiness, but part of a greater circulation. Our world, our sun, even our bodies share this kinship, forged from atoms scattered by ancient stars. To recognize an interstellar visitor is to recognize our own heritage, to remember that we, too, are fragments, carried by forces larger than ourselves. Close your eyes and imagine it. 3i Atlas, slipping away into the dark, its faint tail dissolving into the endless night. Somewhere beyond, another fragment is already on its way, unseen, unknown, destined to pass silently through our sky. The galaxy breathes, and we breathe with it. Let that thought soften the edges of fear. These objects are not threats alone, they are reminders. They teach us that impermanence is universal, that journeys need not have destinations to hold meaning. In their exile, we find reflection. In their silence, we find perspective. And so we rest beneath the same stars, waiting, watching, listening. The next messenger will come, in its own time, carrying with it another whisper from elsewhere. Until then, let the night reassure you. The universe is vast, but it is also shared. Every fragment, every star, every breath is part of one continuum. The night sky is alive. Sleep now, and let it hold